Okay. So, we have discussed in the previous video that to measure skewness and kurtosis, especially to measure skewness in literature, we have two standard formulae proposed by Karl Pearson and Bowley. Karl Pearson coefficient of skewness. And Bowley's coefficient of skewness. Let's see what is the formula for Karl Pearson coefficient of skewness. What that is Sk is equal to mean minus mode by sigma. Mean minus mode by sigma. Okay. Now, we know how to find mean. Okay. If it is a continuous data, we know how to find mean. Also, we know how to find mode. Okay. What would be the formula for mean is, if I have a continuous distribution where there are frequencies and I have X value in terms of class intervals like 10 to 20, 20 to 30 kind, and then I also have frequencies. Then what I'll do is I immediately construct another table. What I'll have Xi, I'll have the range, the class interval. I'm sorry, this is called class interval. Xi would be the midpoint. Xi would nothing be the midpoint of the class interval. Okay. So accordingly, the formula for mean will be summation Fi Xi by capital N, which capital N is again sum of all the frequencies. Now, how do I find mode is, for mode, the formula would be something like mode. This is equal to L plus, L is the lower limit of the modal class, H into F1 minus F0. Okay. 2F1 minus F0 minus F2. Okay. What are F1, F0 and all is? F2 is F0 is the modal class. Okay. F1 is the one which is above the modal class. F2 is the one which is below the modal class. What is H? H is the size of the class interval. L is the lower limit of the class interval. Okay. So I'll be using these formulas to find the mean and mode. Once I know mean and mode, I also know how to find variance, right? Once I have mean, I know how to find variance. What's the formula for variance? Variance would be, how do I find var x? It would be nothing but, of course, if frequencies are there, summation Fi, Xi minus X bar. X bar is nothing but the mu. Summation Fi or capital N I'll be writing. Of course, there should be whole squared, guys. I'm sorry. Variance, for variance, you have whole squared. If it is standard deviation, it is positive root of variance. Okay. So, once I have variance, I know how to find standard deviation sigma, because that is there in the formula as well, right? So I'll be finding sigma and then writing accordingly. Okay. Yeah. So that's those are the formulae for mean, mode, and variance. Okay. Yeah. Suppose if I have a problem, if I have an example to solve, asking me to find the Karl Pearson coefficient, how do I do it? Okay, let's see how do I do it. Yeah, calculate the Karl Pearson coefficient of skewness for the following data. What's it that I've said we'll be needing is, of course, the class interval anyways is there. I don't need actually the class interval because there's a lower limit, there's an upper limit. Also, there's the frequency 18, 20, 30, 22, and 10. Now, midpoint I'll be finding, which would be my Xi. What's the midpoint for 10 and 20? It is 15. 20 and 30, 25. 30 and 40, it's 35, 45, and 55. 10 to 20, 20 to 30, 30 to 40, 40 to 50, and 50 to 60. Okay. Okay. Right. Next, what do I need will be Fi Xi. Fi, Xi, I can just multiply, write the values, take the values, and finally find the summation Fi for the mean. What's mean? I'll be getting summation Fi, Xi. That I'll be substituting summation Fi, Xi. How many values are there? I'll be adding all the frequencies. 22 plus 10 is 32. 32 plus 30 is 62. 62 plus 20 is 82. 82 plus 18 would be 100. Okay. So n would be 100 here. Summation Fi, I'll be getting, I have the value around 3,360 by 100. So it would be something like 33.60. Okay, this is how I'll be finding mean, which everyone is familiar because this is a basic one. Now, how do I find the modal class and how do I find the mode? Okay, for which what I will do is, I'll find the maximum frequency. Okay, maximum frequency would be what? Maximum frequency 18, 20, 30, 22, 10 would be, maximum frequency would be 30. Yeah, the frequency of the, the class interval of the maximum frequency is 30 to 40. Okay. Now, L would be what? L is what? 30. Lower limit of the. And H is what? The difference between each class interval is 20. 10, I'm sorry. Okay. Now, in this, I will be taking, what I will be taking is, this is my F1. Above is my F0, below is my F2. F1 is the modal class, guys. I'm sorry. F1 is the modal class. F1 is the frequency of the modal class. Let me write here. F1 is the frequency of the modal class. Okay. F0 would be the frequency of the above frequency of the modal class. F2 will be the below frequency of the modal. Below the modal class, whatever frequency is there, that values will come. So, mode formula, just see mode formula. Mode formula is what? L. L is what? 30 plus. What's H? 10. 10 into 30 minus F1 minus F0 na? 30 minus 20 by 2 into 30 minus F0 is 20. F2 is 22. Okay. Yeah. I have written with a different color, so you can see. After using a calculator, mode turns out to be 35.555. How do I calculate? Variance are positive root of variance, sigma. How do I calculate this? Under root of summation Fi, x minus x bar whole square by n. Okay. So, of course, you can just calculate x minus x bar. You can again construct a table for this where I'll be having x minus x bar. Mean I have already calculated. Fi into x minus x bar also I can calculate. Okay. So, this value as I have is 12.33. Okay. Now, all this I'll put in the Karl Pearson coefficient of skewness. Formula is very simple. Only thing is if you know the values, then it would be even more simple. What that is mean minus, you know how to calculate the values, then it would be even more simple. Mean minus mode by sigma. Mean has turned out to be 33.6. Mode has turned to be 35.55. And then this standard deviation is 12.33. So SK value is minus 0.58. Okay. So skewness value has turned out to be what? Negative. Okay. So what do you conclude? Karl Pearson coefficient, skewness, SK bounds are what? Minus 3 less than or equal to SK less than or equal to 3. Bowley's is minus 1 less than or equal to SK less than or equal to 1. Okay. So it falls in the negative range. Okay. Probably I can say that it is I have told you, right? Negatively skewed, positively skewed and all. If what it should be there, mean should be maximum and mode should be minimum. In such a case, mean is maximum, mode is minimum. Hence, I can call it to be positively skewed. If it is ulta, what is that? Mode is maximum and mean is minimum, then it is negatively skewed. So I can say that this is positively skewed. If you are asked to find its skewness, if you are asked to write its characteristics like this, you will write. Okay. This is how you will calculate. I'll just end this video.